Section 3.2, Truth Tables for Negation, Conjunction, and Disjunction. A truth table is used to determine when a compound statement is true or false. Here's the truth table for a negation. So we have one simple statement and we have two cases. The simple statement P can be true, in which case the negation of P would be false, or case 2, the simple statement P is false and the negation of P is true. When we're working with two simple statements, P and Q, there are four cases that are listed here. P and Q can both be true. P can be true, Q can be false. P can be false, Q can be true, or both simple statements can be false. Conjunction, remember conjunction, the word and. In this case, the only time the conjunction is going to be true is when both simple statements are true, and that's in case 1. All of the other cases are false. The disjunction truth table, the connective word here is or, and in this case, the disjunction will be true when at least one of the simple statements is true, which occurs in cases 1, 2, and 3. The only time the disjunction is false is when both simple statements are false. The negation of P is read as not P. If P is true, then the negation of P is false. If P is false, the negation of P is true. In other words, the negation of P will always have the opposite truth value of P. The conjunction is read as P and Q is true only when both simple statements P and Q are true. The disjunction is read P or Q is true when either P is true or Q is true, or both P and Q are true. In other words, P or Q is false only when both simple statements P and Q are false. Constructing truth tables. First, you want to determine if the statement is a negation, a conjunction, a conditional, a biconditional, or let's go through those again. Negation, conjunction, disjunction, conditional, or biconditional. The answer to the truth table appears under the column that you've determined for the type of statement it is. Under the negation column, if it's a negation, the conjunction, disjunction, etc. And then I'm going to go ahead and show you, rather than reading these slides, on how we construct a truth table. So we're going to construct a truth table for this compound statement. So the first thing you do is put your cases on the left side. We have two simple statements, so we have 4 cases. These are always going to be set up in the same format on the left side. And then we're going to have a column for each of the either simple statements or decisions, the connectives in the compound statement. And if you notice, I've got a column here for the negation outside the parentheses. I'm going to have a column here for the parenthesis with the negation of Q, for the disjunction, and for P. And I'm going to go inside the parentheses, and the first column I'm going to fill in is negation of Q. So I'm going to take every truth value in the Q column, negate it, take the opposite truth value, and put it into column 1. And so you can see, instead of seeing true, false, we see false, true, false, true. Then I'm going to go over to the P column, and I'm going to bring over the truth values that are shown in the left-hand column for P. And those are true, true, false, false. Now, my first decision in my truth table is in column number 3, and it's a disjunction, and I'm going to say that that compound statement is true when at least one of the simple statements is true. And if I look down the columns here, I see every case is going to be true except case number 3, where I have 2 false simple statements. So I'm going to go ahead and fill in my truth values, and I notice the only time that that compound statement is false is when I have 2 falses, and that happens in case number 3. And then finally, case number 4, I'm going to take all of the truth values in column 3, and I'm going to take the negation of those. That is the opposite truth value. So false, false, true, false. And there's my answer column, the final column in my truth table for that compound statement. Let's do another one. This is an alternative way to set up the truth table. So we've got the 4 cases on the left side, and then I'm going to add columns for not P and not Q. So I'm going to take each of the P truth values, because I need, if I go back for a second, here's what I'm evaluating, not P and not Q. So I put over the negations of the P truth values here, and then the negations of the Q truth values here. And then I'm going to add a column for not P and not Q right over here. And when I add that, now I'm going to make the decision by comparing these 2 columns with the connective of and. The only time this can be true is when both of the simple statements are true, which is in case number 4. The rest of the cases are false. And there's my answer column. When we have 3 simple statements, we're going to construct a truth table for this statement. Santana is home and he is not at his desk, or he is sleeping. So we're going to let P be Santana's at home, Q is Santana's at his desk, and R is going to be he is sleeping. So the first thing we need to do is write this symbolically. Santana is home and he is not at his desk, notice the comma, or he is sleeping. This is what I want to create a truth table for. Now, when we have 3 simple statements, we have 8 cases. And the one thing to notice is the pattern on the truth values. So for P, we see 4 trues followed by 4 falses. For Q, the pattern is true, true, false, false, true, true, false, false. And then for R, we have alternating truth values. This is going to be the 8 cases that we're going to use to build our truth table. So I put the truth table over here, and I'm going to start inside of the parentheses with the P column, which I've already filled in. I've brought over the P truth values. The second column is going to be the not Q inside the parentheses, and I've taken the Q truth values, negated those, and brought them over here. And also, this is a disjunction, so this is where my answer column is going to be, column number 5. Now, my first decision is in column number 3. It's a conjunction. This is only going to be true when both simple statements are true, which I see here in case 3, case 4, and that's the only places. Everything else is false. Now I'm going to go and I'm going to put the truth values in for R, which I've already done, and now I'm going to compare 3 with 4, and the connective here is OR. So this is going to be true when there's at least one true simple statement. So if I look down the column, there's going to be a false in case number 2 and a false in case number 8. Oh, I missed one here. And also in case number 6, all the others are going to be true. So this is my answer column here in column number 5. Write the following compound statement in symbolic form and construct a truth table. The bread is warm and the wine is not chilled. So we'll let P be the bread is warm, the wine is chilled. Write it symbolically, so it's going to be P and conjunction, not Q. Construct the truth table. Now this truth table they do line by line, which is why I wanted to show you this. And we're going to compare, and now we're going to actually do this just line by line without writing the full truth table. You may want to write out the full truth table on paper and then fill in line by line. So in the first one we have P or not Q. So I've got a true, not Q would be a false. So this compound statement in case number 1 is going to be false. Now I've got a true and not Q is going to be a true. Connective is and, so that's going to be true. Then I've got a false and a false, it's going to be false. And then I've got a false and a true, and that's going to be false. So there's another way that you're going to work on some of the problems in my math lab. Determine the truth value of the compound statement, simple statements, and then we're going to do the compound statement. So the compound statement is 1 million is greater than or equal to 1 billion. So there's actually 2 simple statements there. The first one is 1 million is greater than 1 billion. The second one is 1 million is equal to 1 billion. The compound statement can be written as, if you go back and look at it, P is greater than or equal to. So it's going to be P or Q. P and Q are both false. So I substitute the truth values for the simple statements, and the compound statement is false. Determine the truth value for each of the simple statements, and then using those, determine the truth value of the compound statement. Angelina Jolie is an actress, or Zac Efron is a janitor, comma, but Johnny Depp is not a plumber. So here's my 3 simple statements. The first one, and here's the compound statement. Angelina Jolie is an actress, or Zac Efron is a plumber, but Johnny Depp, janitor rather, but Johnny Depp is not a plumber. And we can write this as this. Angelina Jolie is an actress, or Zac Efron is a plumber, in parentheses, but means and, Johnny Depp is not a plumber. Now, truth values. The first one is true. The second one is false. And the third one, this is false, so the negation of R is true. So if we substitute the truth values, we have true or false gives us true, true and true gives us true, so the compound statement is true. Determine the truth value for each simple statement, then use these truth values to determine the truth value of the compound statement. So we'll let P be the first simple statement, 8 plus 7 equals 21 minus 5, and then we'll let Q be 50 minus 5 equals 3 times 9. So P, first we're going to write our compound statement symbolically. P or Q is the first statement here, true or false? Let's simplify it first. So we've got 15 equal to 16, not true, so that's false. And then the second simple statement, we have 10 equal to 9, not true. So we have a false and a false, so our compound statement is false. Use the given table to determine the truth value of each simple statement and then determine the truth value of the compound statement. Region B is larger than region A, or region C is larger than region D. Region B is larger than region A, true or false? That's false. Looking on the table. Region C is larger than region D, true or false? That one's true. And now our compound statement, region B is larger than region A, or, so we actually have a false or a true, so the compound statement is true.